10.3 is about polar coordinates, and let's do some problems. So one important thing to keep in mind is we represent by r comma theta. And any point r comma theta is same as negative r theta plus pi. So this relationship is very important and it will be very useful. And then you can, because the cycle repeats after 2 pi, so this you can relate it as so if I add 2 and pi to both, this is what we get. But the first line is very important. So this is a general one where n can be, integer. So n can be 0 plus minus 1 plus minus 2. So let's do problem 5. So the Cartesian coordinates of a point are given, and we have to find the polar coordinates of the point where r is greater than 0 and then r less than 0. So what is given to us is these are Cartesian coordinates. And the relationship is x is r cos theta and y is r sine theta. So this is an important relation that you have to remember, that x is r cos theta and y is r sine theta. This means that x square plus y square is r square. So if we do that, right, 4 square is 16, negative 4 square is 16 plus another 16. Now for the first part, we want r to be positive. That's the question. So what we are trying to do is we are trying to change negative 4 comma 4 in a form of r comma theta, where for the first part r is greater than 0. So this means r is radical 32. Now what is theta? From here we see that tan theta is y over x, right? Y over x, r cancels out and sine over cos is tan, which 4 and negative 4, y is 4. So tan theta is negative 1. So therefore, beta is 3 pi over 4. So for the first part, the answer becomes now the second part says we have to use R as negative. So now we use this relation that I wrote at the top. Now we know R comma theta. R comma theta is 4 root 2, 3 pi comma 4. So this will give us negative 4 root 2. So that's the final answer. This may look like an easy problem, but this is a very important concept. And there's another part to it. Let's do that as well. Three comma 3 root 3. So again, don't forget that this relation is very important. So now we can find R from here. So 3 root 3 square will be 27. So R square is 36. So in the first part, R has to be positive. This means R is 6. And then tan theta becomes y over x. This means theta is pi over 3. So the answer becomes 6 comma pi over 3. Now for part 2, we want R to be negative. And then we use this relation again. So we start with 6 pi comma 3. So That's the final answer. So if you understand this problem, this will help you understand the entire chapter 10. This is like the building block of chapter 10 or 10.3 and 4. Let's do another type of problem. Let's do problem 17. Identify the curve by finding a Cartesian equation for the. So the curve that is given is we have to find a Cartesian equation, which means y in terms of x or x in terms of y, and identify the curve. So the first step is multiply r to both sides. This gives us now, if you remember from the first problem, we have r square is x square plus y square, and r cos theta is x. But this is not the final answer, because the question is we have to identify the curve. So we have to answer what type of curve such an equation represents. And to see that, so let's complete the square. So you have x square and you have negative 5x. And y square is just y square. So if we complete the perfect square, you see a negative here, and then you should remember this formula. So a square is like x square, and negative 5x is like negative 2ab. So now we need to figure out what could be b. A is x, we have x here, and we have 2. So it means b is 5/2. So to change this into this form, we add and subtract b square. So we add b square and subtract b square to this equation. Because adding and subtracting does not change anything. Let's just keep it like that. So this is the final equation. And what curve is this? So this is a circle with radius 5/2. You see, because x square plus y square is r square. But x is shifted by 5/2 units. So this has a center at negative 5/2, 0. Correction, this is negative here. And then the center will be positive. Why this should be negative? Because we have negative 5x. So this negative 5x means this is a negative square. So which makes center as positive 5. So this is another type of problem, an important problem, an easy problem. Now let's move to more confusing part, which is the sketches. So let's first do problem 35. So now we've sketched the curve with given polar equation by first sketching the graph of r as a function of theta in Cartesian coordinates. So r is 3 times cos 3 theta. So first we have to sketch the graph of r as a function of theta. To do that, let's make two rows, theta and r. Now what values of theta should we consider? Because it's 3 theta. So we will take theta to be, we'll start from 0. And cos 0 is 1, so r is 3. So after 0, because it's 3 theta, let's make theta as pi/6. So cos of 3 times pi/6 will be pi/2, which is 0. Then we will increase by pi/6 interval. So we will increase theta by pi/6. So we get 2 pi/6, which is same as pi/3. 3 times pi/3 is pi. So cos pi is -1 times 3, -3. Next we get, so this was pi/6, 2 pi/6, 3 pi/6, which is pi/2. Cos 3 pi/2 is 0. We can go up till pi. So next we get pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, which is same as 2 pi over 3. And cos 2 pi is 1, so we get 3. Next we get 5 pi over 6. Cos 5 pi over 2 will be 0. And next we reach pi. Cos 3 pi is negative 1. So this table is very important and it will carry a lot of partial credit. Now let's sketch this. First, the graph of R as function of theta. So R is a cos function, so the graph should look like cos. So when theta is 0, R is 3. So we start from 3. So we start from 3 and we come down, go to minus 3. Then we go up to 3 again. Then we come down, go to minus 3. Then labeling on the curve is very important. So we start from 0, R is 3. And pi over 6, R is 0. So this is pi over 6. Then R is negative 3 at pi over 3. Then it's 0 again at pi over 2. And then it's positive 3 at 2 pi over 3. Then it's 0 again. And then it's negative 3 at pi. So this cycle can repeat. You can stretch it to 2 pi as well. So this is one period. So this is the cycle. That's not relevant, but you can sketch, you can repeat this as much as you want. And this is only the graph of R. Now we have to sketch the curve. So since because you have a 3 here, 3 is odd. So that's why you have a sketch would be 3-leaved. And then they call it flower or rose. Let me check. So they call it rose, 3-leaved rose. Because 3 is odd. For the even, you have to multiply by 2. So let's draw 3-leaf rows, but we have to be careful. First, note that this table is very important. So when theta is 0, r starts from 3, and then every pi over 6 interval, it goes from 3, 0, negative 3, 0, 3, 0, negative 3. So pi over 6 interval is very important. So first, just for reference, mark this line, theta equals pi over 6. Let me bring it in. We mark a similar line here. So first part is mark pi over 6, both above and below the axis. So above is pi over 6, below it's 5 pi over 6. And then just extend it to the other side. That's not very good. So now we start with 3 when theta is 0. So this is theta equals 0. And we can call this much as 3. So we start from here. And when we move to pi over 6, we end up at 0. So, right. And then right. So we start from here, goes like this. So we start from 3, go to 0, then negative 3, come back to 0, now go to positive 3, come back to 0, and then finally rounding it up. And so this should lie like above this line, this above dot. So this point you can label as 3, 0. So that's a 3-leaf rows. The most important part first, draw this table, then draw the graph, and then now you know this is a cos and it's a odd, so it's odd leafed rows. Then try to draw it, but it should follow this table. So like when theta is 0, we start with 3. And then as we go to pi over 6, we are coming back to 0. And then we go further ahead, we are getting negative 3, Now to understand this negatives, remember the relation that I told you earlier, that this r theta is same as negative r theta plus pi. So if you understand this, that will help you for the sketches as well. Let's do some more sketches of different kinds. Before I write a specific problem, let's try to remember these four things. This is 1 minus. So 1 plus sine theta, 1 minus sine theta, 1 plus cos theta, 1 minus cos theta. It should be cos theta. Let's try to write for what r is for some 2 values of theta, 2 to 3 values. So let's say theta equals 0, theta equal pi over 2, theta equals pi. So when theta is 0, this is 1, this is 1, this is 2, this is 0, right? So sine theta is 0, cos theta is 1. Now for pi over 2, sine pi over 2 is 1, cos pi over 2 is 0. For pi, sine pi is 0, cos pi is negative 1. Now let's try to draw some sketch. This length is 2, so it's like 2 comma pi over 2, and this length is 1. This is 1 comma 0. So now what this curve, so we see at theta pi over 2, you have 2, theta 0, you have 1, theta pi, you also have 1. And I have 1 comma pi. So this curve is like 1, 2, 1. So 1, 2, 1 here is 1, 2, 1, 1 plus sine theta. So this is r equals 1 plus sine theta. Similarly, theta equals 0, theta equals pi over 2, theta equals pi. This point is 1 comma 0. This is 0 comma pi over 2. One comma pi. And then this will be 2 comma 3 pi over 2. Although I have not written what will be 3 pi over 2, but you can check that 1, 0, 1 is 1 minus sine theta. Right? Theta 0, it's 1. Theta pi over 2 is 0. Theta pi is 1, 1, 0, 1. And then if you go beyond 3 pi over 2, sine theta will be negative 1 and we will get 2. This curve is then 1 minus sine theta. Similarly, we can draw so here you have 0 comma 1. No, sorry, 0 comma 2. 0 comma 2. The notation is r comma theta. So it should be 2 comma 0. And then 1 comma pi over 2. And then here you have 0 comma pi. So you have 2, 1, 0. Right? So this is this curve 1 plus cos theta. So when theta is 0, it's 2. Theta pi over 2 is 1. Theta pi is 0. Theta 0, 2. Theta pi over 2, 1. Theta pi is 0. So this is r equals 1 plus cos theta. Similarly, so you have 0 comma 0, 1 comma pi over 2, 2 comma pi. So you have 0, 1, 2, 0, 1, 2. So this curve becomes r equals 1 minus cos theta. So the reason I did this, these are the 4 basic sketches. The other one you will see, we will just do simple modification over this to solve some other problem. So now, for example, let's look at problem 39. Now the difference here between this curve and the one above it, r1 plus cos theta, is that we have a 3 here instead of 1. But still, in order to draw this curve, this will form as our template. So what I mean is, some points, we will determine what these points are. So this is the template I'm using to draw this. Because the only difference is it's 1 plus cos theta is 1 plus 3 cos theta. But instead of coming back like this, I will go up and then like that. So let me make this better. I will go up and then come down. But this is incomplete because we have not labeled it, what these points are. This is now a sketch without labeling. To label it, let's draw the table that we do. Theta r. Just make theta as 0, pi over 2, pi. When theta is 0, cos 0 is 1, 1 plus 3, 4. Theta is pi over 2, cos pi over 2 is 0, 1. Cos pi is negative 1, cos 3 pi over 2 is 0. And you can extend it for more values. So let's see. So this is theta equals 0. When theta is 0, r is 4. So this point becomes 4, 0. Now we move to theta equals pi over 2. And theta is pi over 2, r is 1. So this point is 1, pi over 2. Now note, when theta is pi, r is negative 2. So this point is negative 2, pi. So this is a new part here, negative 2, pi. And you can see this is same as, so note, if you recall, negative 2 comma pi is same as 2 comma 0. So using the same thing, minus r comma theta plus pi, same as r comma theta, which is what I was discussing earlier. So it's negative 2 comma pi is at the same location as 2 comma 0. Now this completes this sketch, and similarly you can now have 1 comma 3 pi over 2. And then cycle repeats. But one last thing is left is we have to sketch the graph of R. Let's just draw it. So R is a cos function. It is shifted by 1. So we start with 4. Theta 0 R is 4. So we start from 4, come here, down. And we come back here. And this is 2 pi. And then you can find this point where this will go to 0. So here cos theta is negative 1/3. So whatever that point will be. But the important thing is write R corresponding to some values of theta. And then this is the most important sketch. So just to recap, because this is 1 plus R 3 cos theta, so our template was 1 plus cos theta. And we just, instead of ending it here, we extended it like that. Another circle, another loop. And from the values of R at different thetas, we label them and then we plotted the R. Let's see if there's one more example like that. Right, so we can do one more example. Problem number 40. R equals 1 plus 5 sine theta. Now because it's 1 plus 5 sine theta, and if you recall, 1 plus sine theta looks like this. So 5 sine theta will be something of a loop here. So if we just add a loop to 1 plus sine theta, and then label the points properly. That will be 1 plus 5 sine theta. This is a rough sketch of 1 plus 5 sine theta. Next, we have to label the points. So let's write down theta r. Theta is 0, sine 0 is 0, r is 1. So this means this point is 1 comma 0, right? But this is theta equals 0. Next, we move to theta equals pi over 2. Sine pi over 2 is 1, so we get 6. So this point is 6 comma pi over 2. Next, we go to pi. Sine pi is 0. So this point is 1 comma pi. Next, we go to 3 pi over 2. Sine theta is negative 1, so you get negative 4. So this point is negative 4 comma 3 pi. And similarly, you can go to 2 pi and it will be 1 again. That's like coming back to this point. Now, once you have r, you can also draw a graph of r. And if we have to draw it every time, because the question asks 3 things: the main sketch, the table, and then graph of r. So when theta is 0, r is 1. So we start from here. We go up till 6. Come back to 1. And go up till negative 4. And then we can come back to 1. And these points where it crosses, you can see sine theta should be negative 1 over 5. So whatever that angle is, go to that. So this completes the sketch part of it. And now you can practice more problems like that. Now let's move to a different type of problem. This is 63. We have to find the points on the given curve where the tangent line is horizontal or vertical. So the question is, first part is, given a curve like this, what will be dy over dx? Slope of tangent. So if you recall, r is x cos theta. So it means dr over d theta is it's the other way around. X is r cos theta. So now theta is like the parameter t of 10.2. So dx over theta is because r depends on theta, plus we have product rule. Right. Because derivative of cos is negative sine. And y is r sine theta. Product rule. So now dy over dx will be, we just divide these two. But for the given problem, let's compute what is dr over d theta, because we need dr over d theta. It's negative sine theta. Right. So now if I substitute negative sine theta here and divide these two, my dy over dx is dy over d theta dx over d theta. And dx over d theta is dr over d theta, which is negative sine theta times cos theta plus r times negative sine. So this is the numerator and this is the denominator. R is given by this 1 plus constant. So if you just simplify a little bit, so I've extracted a common factor of sine theta in the denominator, and the numerator is just you multiply, which is we can replace this negative sine square using the identity sine square plus cos square is 1. So we get this is dy over dx. Now the question is we have to find at what angles this is vertical and for what angles this is horizontal. So horizontal means numerator is 0. We can factorize. So you get theta equals so pi comes from here and these comes from here. Now for vertical, The denominator should be 0. So this should be 0. So this means sine theta equals 0, or theta is 0 comma pi, and from here theta is 4 pi. Now if you observe, theta equals pi is present in both. So for that, you have to check what happens when you take the limit and this limit is 0. Therefore, theta equals pi will be horizontal. So this is correct, and you have to discard this. Because of this limit. This is the tricky part, but I don't expect it to be in the test because it's tricky. But still you should be able to compute the dy by dx and the values of theta the way I've computed. So vertical is theta 0, 2 pi over 3, 4 pi over 3. Horizontal is theta pi, pi over 3, 5 pi over 3. Yeah. But this is the most important part.